Welcome to 56-Bit Cloud Cafe, your go-to destination for all tech topics in the cloud. I'm Athir Zalat.
And I'm Patrick Camilleri. And together we'll be addressing various cloud topics.
Hello everyone and welcome back. In this episode, we are exploring the exciting world of deploying applications on Amazon EKS, from setup tips to optimization tricks. Join us as we uncover the secrets to seamless application deployment in the cloud with Amazon EKS. So let's start. Simplified processes are what make AWS stand out in the public clouds market. What are the steps involved in deploying an application on Amazon EKS?
To deploy your application on EKS, it's not very different from deploying to any other Kubernetes cluster. So if you have that knowledge, it's quite easy and very similar. Basically, it involves creating a container image. If you're using Docker, you would use the Docker CLI, for example, or any other software which makes sense to make that image using Docker build, and then you would push that image towards a container registry, which saves this image so that it can be run eventually by EKS. This can be Elastic Container Service, registry, ECR on AWS. It can be external registries or private registries as well. Wherever you're saving that image, then you would need to define a manifest file, basically Kubernetes manifest files, which are in the YAML format. These allow you to define certain rules. How many containers do you want running from that image? Whether they should be in different availability zones, whether they should be as part of a service, which we'll talk about later. The storage requirements, the load balancing requirements, all these things, you will set them out in YAML format in that Kubernetes manifest file. And then you join those two together, right? So you have the image in a registry and you have the rules in a file. You use a tool like kubectl or any other deployment tool that communicates with Kubernetes. There are even ones that are specific to EKS if you wish. And you would use that to deploy the application. So basically, using those manifest file, you are telling Kubernetes what you want to do, from where it should get that container, the image which is stored, and how many of those containers to run, etc., etc. So the rules are used to basically deploy your application, and from there EKS takes care of the rest. So it will deploy the containers, the pods, onto those worker nodes. It will manage their life cycle, will make sure that they remain up, depending on those rules ultimately.
Okay, perfect. Now, as we all know, components of the EKS are several and each has its own utility. Can you explain the role of Kubernetes namespaces in Amazon EKS deployments?
Yes, namespaces are a very important concept in Kubernetes in general, and thus also EKS. Namespaces allow you to isolate. And isolation is a very important aspect in IT, where you have workloads which do something. They are completely separate, isolated, logically isolated, not physically, away from other workloads which may do something else. So as an example of this, we might have a development environment, a staging environment, and a production environment. 3 different workloads used for different use cases, right? One to develop, one to test, one in production. And you can split these environments from each other, but using the same Kubernetes cluster, and that split is done through namespaces. So the namespaces will limit any damage that you might do from one environment to the other. So if you have do something bad in one environment, it will not affect the other environment. So there is a security element to this, and Kubernetes will take care of the splitting, logically isolating the networking, the pods, where they run, how they run. So it is a very clean and easy to use inbuilt mechanism of isolation in Kubernetes.
Now, I would like to ask you, networking in monolithic application differ completely from the containerized approach, right? How does Amazon EKS manage container networking and communication within a cluster?
Obviously, networking is important in IT, it's important when it comes to servers, it's important when it comes to containers and Kubernetes as well. And networking is the basic structure which allows you to communicate from outside of Kubernetes cluster to inside the cluster, as well as between the different workloads and different containers inside that cluster. EKS and Kubernetes use a container network interface, a CNI plugin, right? It's a piece of software that runs inside those pods that allow the communication between the pods as well as towards Kubernetes itself, the software itself. The pods can communicate between each other using DNS or using IP addresses. They can communicate to the external world using DNS or IP addresses. All of this can be controlled from a security standpoint using rules in that Kubernetes manifest files. Another important aspect here from a networking perspective is services. Services are a single endpoint, a single name that is used to refer to a whole application inside a namespace. So let's say you have 20 containers running the same piece of software, your front end. Now, from outside of Kubernetes, you shouldn't be talking to a single container. You shouldn't be referencing a single container, but rather you should be talking to an endpoint. And this endpoint will be a generic endpoint which allows load balancing between those different containers. This is known as a service endpoint, and it allows, for example, elastic load balancing, ELB, to communicate with one or more pods in that service.
So now at this point, the application is deployed and functional with EKS. What are some best practices for optimizing application performance and resource utilization on Amazon EKS?
Optimization in EKS is very similar to optimization in any other Kubernetes cluster. It involves making sure that, for example, your worker nodes are of the right size, that they are not too large, so you don't waste money, but they're also not too small, which will end up increasing the amount of work Kubernetes needs to do in terms of orchestrating between servers in that cluster. So right sizing is very important, making sure that your pods can run efficiently with enough memory, enough CPU, and enough networking power. You can set limits, quotas in Kubernetes to ensure that you control resources, so you don't bring up too many pods, or the namespace can be controlled in terms of these limits. It's important as well to think of auto-scaling. You should have a service which allows auto-scaling of those pods to make sure that they can scale out and scale back in according to the amount of traffic coming in or according to patterns that you set. Ultimately, an important best practice is always to monitor and log and the metrics and the logs coming from Kubernetes. So this from EKS, which obviously runs Kubernetes, and there is already a good integration with CloudWatch showing you some basic metrics and logs which will give you an indication of the patterns that your pods are doing, what they are doing under the hood, and that should give you an indication of where you can increase or decrease limits, maybe find patterns from an optimization perspective. This can be security optimization, can be price optimization, can be scalability, and other aspects that we always use in different AWS services.
Despite it being managed, there is still an element of maintenance we need to take care of. How does Amazon EKS support rolling updates and canary deployments for applications?
So updating your software is an important aspect of any software. It's not just about launching the software, but it's also important to launch new versions of that software in a way which doesn't bring down the old version until the new version is fully rolled out. This is an important aspect of DevOps, and rolling updates is one methodology of how to do that. Kubernetes allows you to very quickly, literally with a single command, do such a rolling update. Rolling updates, basically, they gradually deploy new applications, version 2 of an application, by replacing pods with new ones. So bringing down a pod, bringing up another one, bringing down one, bringing up one. And this allows a rolling update, meaning that there is still enough pods to handle current traffic, but eventually the new versions will take over. And EKS can do this with very minimal downtime and very, very easily in terms of how to trigger such an update. Canary deployments is another methodology. It allows you to use a small subset of pods. Let's say you have 100 pods running a specific workload. You can use 5 of those pods for version 2. So you know that 5% of your traffic is going towards version 2, and you can thus test it in a statistical way, test what is happening, and if all goes well, you can then do a rolling update to the rest of the pods.
And that's a wrap on deploying applications on Amazon EKS. We hope you're feeling confident and ready to tackle your own deployments on the cloud. Don't forget to join us next time as we delve into monitoring and managing Amazon EKS clusters. Until then, happy cloud computing!
If you have questions, suggestions, or want to share your feedback, connect with us on social media.
Also, don't forget to subscribe to our podcast and to leave us a review to help others find their way to the Cloud Cafe.